Hello, class. We have introduced the preliminary mix design of concrete mix design in last class, and the theme of today's class is the reference mix, laboratory mix, and construction mix design of concrete. First, based on the results of the preliminary mix design, conduct trial mix design. All materials used in the trial mix should be the same as those used in the actual project. The weighing of coarse and fine aggregates should be based on the dry state. But what if they are not dry? The water absorbed by aggregates should be deducted from the mixing water, and the corresponding amount of aggregates should be increased. Concrete mixing can be done using a forced mixer or manual mixing. After mixing, the workability of concrete should be tested. If the slump or VB time of the mixed concrete does not meet the construction requirements, or if the cohesion and water retention are poor, the water content or sand ratio should be adjusted accordingly, while maintaining the water binder ratio constant. For example, if the measured slump value is less than the design requirement, the amount of cementitious materials and water can be increased under the condition of constant water binder ratio. After adjustment, the workability of the obtained concrete should meet the design requirements, thus obtaining the reference mix design. To test the strength of concrete, at least 3 different mix designs should be developed. When using 3 different mix designs, one water binder ratio serves as the reference mix design, while the water binder ratio of the other 2 mix designs should be increased and decreased by 0.05 or 0.1 respectively, based on the reference mix design. The mixing water content is the same as that of the reference mix design, and the sand ratio can be increased or decreased by 1%. After preparing test specimens, the slump or VB time, cohesion, water retention, and apparent density of the mixture should be tested. To test the strength of concrete, at least one set of specimens should be prepared for each mix design and cured for 28 days under specified conditions, or for the designated age, and then tested for compressive strength. Based on the test results, plot the relationship curve between the 28-day compressive strength of concrete cubes and the water binder ratio, as shown in the diagram above. As we've introduced before, the strength of concrete is inversely proportional to the water binder ratio, which means it is directly proportional to the cement content. 3 different water binder ratios result in 3 different cement contents. These 3 cement contents correspond to 3 points. By linear regression, these points form a straight line. On this graph, we can directly refer to the cement content corresponding to the desired strength of concrete mix. After determining the cement content corresponding to the desired concrete strength, the quantities of each material per cubic meter of concrete are determined according to the following principles. Firstly, based on the reference mix design, the amount of mixing water and admixtures should be adjusted according to the determined water binder ratio. The amount of cementitious materials can be adjusted based on the water binder ratio and the amount of mixing water. When adjusting the amounts of coarse and fine aggregates, either the mass method or volume method can still be used. The amounts of coarse and fine aggregates are determined through calculation, and the mix design of concrete is revised based on the strength test results. Additionally, calculate the calculated apparent density of the concrete mixture. which is obtained by summing the masses of all constituent materials, resulting in the calculated apparent density of concrete. Furthermore, based on the measured apparent density of concrete, the correction factor for the concrete mix design can be calculated. When the absolute difference between the measured and calculated apparent densities of concrete does not exceed 2% of the calculated value, that is, when the correction factor is less than 1.02, the mix design revised according to the strength test results is the determined laboratory mix design. When the difference between them exceeds 2%, that is, when the correction factor exceeds 1.02, the quantities of each component material in the mix design should be multiplied by the corresponding correction factor to obtain the final laboratory mix design. In summary, based on the reference mix design, determine the optional water binder ratio while keeping the water content and sand ratio constant to establish the laboratory mix design. The materials obtained from the calculation of the laboratory mix design of concrete are based on dry aggregates. However, aggregates are often stored in open air at construction sites, resulting in a certain moisture content in the aggregates. Therefore, at the construction site, the laboratory mix design should be converted into the construction mix design based on the variation in moisture content of aggregates at the site. Assuming that the moisture content of aggregates at the construction site is measured to be A% and B% respectively, the quantities of materials in the construction mix design are determined through calculation as shown in the diagram. Cementitious materials do not consider moisture content, while the quantity of aggregates needs to be adjusted due to their moisture content. Should the amount of mixing water be adjusted as well? Since aggregates contain water, the amount of mixing water should be reduced accordingly to account for the water content in aggregates. It should be noted that in both laboratory and construction mix designs, the quantity of cementitious materials remains constant, while the amounts of water, sand, and aggregates are adjusted accordingly to the moisture content. However, the water binder ratio should remain constant. Both laboratory and construction mix designs should meet the workability requirements of construction. Thus, we have completed the entire process of concrete mix design. In this class, we mainly discussed the entire process of concrete mix design, including the reference mix design, laboratory mix design, and construction mix design. The mix design of concrete directly affects the quality of concrete. Therefore, it is essential to strive for precision in the calculation process, ensuring the quality of the project and paying attention to every detail. After all, the quality of the project is the relentless pursuit of every engineer. Only by vigorously improving the quality of the project can we contribute to building a quality-oriented nation. Please, students, think about 1. The definition formula of moisture content. 2. If the moisture content of wet sand is 5% and its weight is 105 grams, what are the weights of water and dry sand respectively? Thank you for listening attentively to this micro lesson. Goodbye and see you again.